Welcome, everyone. I know you all are accustomed to seeing me in front of my green screen with fancy animations and magic tricks and all that fun stuff, but green screen takes a lot of time, and I don't want to haul it out and set it up, and it also takes me a while to edit everything. So we're gonna do this discussion just by screen capture, and it's one I've been wanting to do for a long time, and one that I hope you all enjoy. Today's discussion is about database analysis and design, and we're going to talk about two important programs that are involved in database analysis and design. One is Microsoft Visio, which you see right now, and the other one is Microsoft Access. Both of these are very useful for database design, and we're going to talk about what each of them does for us during this little talk. This is going to last, I don't know, maybe an hour. I haven't practiced it, so we'll see how it goes. And let's begin. So, as you know from your study of maybe systems analysis and design or software engineering or whatever you might have studied in the past, everything begins with a business problem, or in this case, it begins with some kind of data management need. And a data management need can be one of many things. So we might need a human resource information system. For those of you who know me, know I worked in HRIS for 6 years for the United States Army, so it's one of the things I'm very familiar with. You also might be creating a database for a collection, or you might be creating a database for a student information system is very often used as examples in these cases. There are lots and lots of data management needs. So let's write them down. So we need a collection or a student information system, or we might have a, what did we say? We said I'm so much better at this with a live audience. Let's see. Collection, a student information system. What else do we need? Call something out. Maybe I'll hear it through the internet. An HRIS, a human resource information system. So these are some typical possibilities. And what'll happen is when you're designing your system, or when you're coming up with the idea, the client's going to come to you and say, I need something that's going to help me manage this. I need something that's going to help me manage my collection of DVDs. I need something that's going to help me manage all of my students, their classes, and the professors. Or I need something that's going to help me manage my employees. That's going to be the need that we're trying to fill with the creation of this database system. Once you've identified your need, you start by, now we're not going through an entire systems development lifecycle here. So we're going to be skipping a lot of steps. We're going to be skipping the feasibility study. We're going to be skipping, we're just going to be skipping a lot of things, but we're just going to talk about how to design databases in this little talk. I'm going to have another one on systems analysis and design. I've filmed it, but I haven't edited it all together yet because it takes, as I said, it takes a while to do all the green screen effects. All right, so once we've identified our data management need, let's pick, I don't know, the collection, because that's an easy one to do. Once we've identified our data management need, we start by creating a list of entities. And an entity is some kind of object that's going to be modeled in the real world. An example is a book. A book is an entity. So if we're doing a collection, let's say we're doing a DVD collection. A DVD is an entity. Now, when I do this talk live, a lot of time when I ask for more entities, my students will say, the book's title, or sorry, the DVD's title is an entity. No, the DVD's title is not an entity. The DVD's title is actually an attribute of that entity. So we can create our list of entities. So a DVD is an entity, and we can say a title is an attribute. So I'm going to put that underneath of the DVD. But we need to decide what are the other entities in this system. The entity is some kind of object that's going to be modeled in the real world. So in a collection of DVDs, we have the DVDs themselves. What else might we have? Well, we might have a director. And note that a director can direct many DVDs. So a director might be in our collection. An actor might be in our collection. These are all things that might be needed to be modeled in our collection. When you're trying to decide if something is an entity or an attribute, think of its atomicity. Here's another word. Attributes are atomic properties of an entity. So if you're thinking of all the stuff that might be in your database, an entity is some object, and that object has attributes. It has properties. And if you think of something else like, I don't know, a title is what we call atomic. We can't break a title down into its component parts and have it still be meaningful. Yes, we can say a title has letters and numbers, and we can say that the letter at index 0 is this, the letter at index 5 is this, but really a title is just a title. It has no component parts. We can't break it down any further. That means a title is an attribute. Director. Let's talk about a director. A director has many component parts. He or she has a name. Actually, let's say a first name, a last name. Let's leave that for now. An actor also has a first name and a last name. So when we think about attributes and entities, we want to think about atomicity. An entity is something that can be broken down into its component parts. A DVD can be broken down into its title. A DVD also has a rating, whether it was G, PG, R, etc. Something else that a DVD might have is a description. Or let's call it a synopsis. And actually, I don't like DVD. I want to do movie. Because nobody collects physical DVDs anymore. So we just want to do a collection of our movies. So a movie has a title, a synopsis, a rating. What else might it have? Think about it for a second. Think about it in your head, and let's see if we come up with the same things. I feel like I'm on Blue's Clues or something. Do you see it? Do you see what Blue's pointing to? What's Blue pointing to? All right. So you got it in your head. What else might be an attribute of a movie? That is, the component parts of a movie that are themselves atomic. That is, they're not able to be split into different pieces. The title can't be split into different pieces. The synopsis can't be split into different pieces. The rating can't be split into different pieces. How about the year it was released? Release year. Maybe a production company. Let's talk about the production company. The production company could probably be broken up into its component parts, in which case we probably want to make the production company an entity and not an attribute. And a production company has a name, an address, what else does a production company have? I don't know, maybe a name and an address. Well, that works okay for me. What else could be a property of a movie? Let's see. Synopsis, release year, its rating. Let me go grab a DVD off my shelf, because I have DVDs that are old. All right. For those of you who know me, you know I love the Power Rangers, so I grabbed the Mighty Morphin Power Rangers movie. All right. It also has a distributor. A distributor could be just like a production company can be split into its component parts. A distributor could also be split into its component parts. So let's say distributor. And a distributor also has a name and an address, just like a production company. Let's see, what else is back here? It has costume designer, editor. Yeah, that's enough for me. I'm good with that. So these are our entities. Let's go about picking data types for these. Let's talk about data types for a few seconds. Data types. Data types are the ways we describe valid values that can be put into our attributes. And there are numerous data types, and depending on the database management system you use, they might be called different things. But there are some basic ones that we have. We have, for example, a title is a list of characters, a list of A, B, C, D, etc. And we call that a varchar. Or some people say char. I hate when people say char. Varchar. A variable length character field. Variable length character field. And because it's a variable length, we have to set a maximum length. So usually I like to make these powers of 2. And it can be, when we say a varchar, it can be anything from 0 to whatever that amount is. So for a movie's title, we can have something as simple as it, which is 2 characters. Or we can have something very, very long like To Wong Fu, Thanks for Everything, Julie Newmar, very, very long movie title. I'm going to go with 32. Usually I like powers of 2. And I want to make this a varchar type 32. When we do this, we say colon varchar 32. Synopsis. Think about what that might be. Think about synopsis. Synopsis is a string of characters, A, B, C, D, 1, 2, 3. It's also going to be varchar. And a synopsis can be very large. So we can say varchar 512, maybe. There's also the option, if we have no idea what the maximum amount is going to be, we can say varchar max. And what varchar max allows us to do is say this can be however large it needs to be. We want to use this one sparingly because depending on the implementation, it might allocate a lot. The database management system might allocate a lot more space than necessary, or it might store it inefficiently. So we want to, if at all possible, pick a maximum value. And if that maximum value is reached, sorry, we have to make the value smaller. So I'm going to pick 512, or maybe 1024. You might have a really long synopsis. 1024 characters. Now, rating. Rating is an interesting one because rating has a very finite number of values. It can be G, PG. Well, actually, let's do NR, no rating. G, PG, PG-13, R, and NC-17. Those are the only ratings that exist. There's 6 of them. It's a very finite list of ratings. So let's look at the smallest one is G, just 1 character. And the largest one is our PG-13 and NC-17. They're 5 characters each. So this one is going to be varchar 5. This is one of the exceptions when I don't do powers of 2. And for those of you who are familiar with binary, you know that I use powers of 2 because that's how data are stored inside of our computer. Usually things are allocated in powers of 2. Space is allocated in powers of 2. This is usually the only time where I will deviate from that, when I know the maximum will be something that's not a power of 2. Usually inside the system, this will probably allocate 8 bits for it. Or sorry, 8 bytes. Just it'll round up to the next power of 2. But I'm going to put 5 just because we want that to stay there. So far we've only used varchars. And now, some of you may be wondering, well, if there are only a finite number of values, how do we enforce that in our database? Well, I'll show you how we can do that in a little bit. So let's talk about release year. Release year is a funny one, and you can pick 2 different possibilities, and it's up to you what you want to do. When you make design decisions, there are trade-offs, there are considerations. As long as you pick something that makes sense, nobody's going to fault you for it. There are some people who may have preferences one way or the other, but as long as it makes sense what you're doing, nobody's going to think the less of you. So there are 2 options here. We have another data type called int, or integer. And for those of you familiar with arithmetic, you know an integer is any whole number. Yeah, any whole number. Whether it's a negative infinity or positive infinity, they're all integers. 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, -2, -3, those are all integers. We have a couple variants on integers. We have int, tiny int, and big int. Tiny int and big int are rarely used. For many applications, tiny int is more appropriate, but it's just not used for no other reason than it's uh, it's just not used. There's really no reason why, except it's not really intuitive for somebody to think tiny int versus int. If it's an integer, it's an integer. Nobody really thinks about how long it's going to be. Integer usually is going to be 32 bits wide. It might not be, depending on the database management system you're using and the architecture you're using. It might not be. It might be something different. Usually it's 32 bits wide. It's signed, that is, it can be negative or positive. Let's write these down. It's signed, it can be negative or positive. And this means for 32 bits, hey Siri, what is 2 to the 32nd power?
Cogitating. The answer is 4,294,967,296.
All right, so because it's signed, actually it's half that. So, hey Siri, what is 2 to the 31st power?
Let's see. The answer is 2,147,483,648.
All right, so there we go. Thank you, Siri. All right, so Siri says when we have 32 bits, we can have between negative 2 billion-ish and positive 2 billion-ish. That's the possible range of values. And for those of you who understand binary, you know why that is. For tiny int, it's usually either 8 or 16 bits wide, depending on the architecture. It's signed. And hey Siri, what's 2 to the 8th power?
Let's see. The answer is 256.
All right, so it's between, sorry, what's 2 to the 7th power? That's half of 256, which is 128. So if it's 8 bits wide, that gives us a possible values between negative 128 and positive 128 for 8 bits. If it's 16 bits wide, hey Siri, what's 2 to the 15th power?
I believe someone just asked me this the other day. Give me a sec. The answer is 32,768.
Thanks, Siri. Okay, so for a 16-bit wide tiny int, it's between negative 32,768 and positive 32,768 for 16 bits. And again, those of you who understand binary, you know why that is. Just for those of you who don't understand binary and are just looking at this for database management's sake, just take my word on it. And then we also have big int. And big int can either be, depending on how it's implemented, it can either be an integer of arbitrarily large size, that means however large the memory of the computer will hold, that's how big it can be. So it can either be arbitrarily large, sometimes it's 64 bits. It all depends on the implementation and what you are, and which database management system you're using. So let's talk about dates or years again. We want to be able to represent a 4-digit year, because no movie has been produced before 1920 something. And so far, no movie has been produced past 2016. So we really only need to represent numbers between 1920-ish and 2016 right now when I'm filming this. Though we do want to be able to represent movies in the future. We want to be able to represent 2017, 2018, 2019, maybe 3000 eventually if this system is going to last that long, which it probably won't. But we want to be able to represent movies that are going to be in the future. So we want to be able to represent something in the range of of 1920. Nothing's going to be done before then. And at least till, let's say, 3000. Year 3K. What should we choose? We can choose an integer, but in this case, an integer's overkill. An integer allows us to represent negative 2 billion-ish to positive 2 billion-ish. We don't need that much space. A tiny int, actually this is sometimes called a small int. A tiny int is 8 or 16 bits wide, and it can represent between negative 32,000 and positive 32,000. For our purposes, a tiny int, or a small int, is probably more appropriate. And I'll tell you that in Microsoft Access, small int is negative 32,000 and positive 32,000. It's 16 bits wide. So for a year, it might be appropriate to pick small int or tiny int. We have another option. Because we always want to represent a 4-digit year, we can use a different type of character field, and that is just char. Not varchar, but char. It's not a variable length character field. But a fixed length character field. And that's our other option. We can say it's either small int or char of length 4, exactly 4. And it's entirely up to you. Now, if you pick character of length 4, you may run into some issues because it's possible that somebody could pick ABCD, and that is perfectly valid. The string ABCD is perfectly valid for character of length 4. However, if you pick small int, ABCD is not valid. So if you pick character of length 4, you're going to have to put some validation on your field, and I'll show you how to do that later. If you pick small int, you might also have to put some validation on your field. For example, you want to make sure that it's not less than 0, or let's say not less than 1900, because there were no movies produced before that. Hey Siri, in what year was the very first motion picture produced?
Looking. My web search turned something up for in what year was the very first motion picture produced.
Siri doesn't know. But anyway, you want to be able to make sure it's a valid range. And again, I'll show you how to do that. Now, when we come to directors and actors, things get kind of confusing, or they get kind of hazy. Because it's possible for someone to be a director and an actor. Someone who's directed and acted before might include, I don't know. David Moore may have both directed and acted before. Ben Affleck. Ben Affleck is somebody who directs and acts. So Ben Affleck would have to exist as a director and as an actor. So I don't want to store it this way. This is why, when you study systems analysis and design, you have to do the analysis and design before you do the implementation. You have to design your database before you go implementing it. Because you get to decide all of these things before you actually go and write any code. I've often had people ask me, can I use the database diagram inside Microsoft Access? And can I call that an entity relationship diagram? I'll talk about entity relationship diagrams in a bit. The answer is no. You can't. Because if you use the... I'll talk about that a little bit. Do not write any code. Do not create any tables. Do not create any entities. Don't create any queries. Nothing. Until you have completely designed your entire database. Because you can avoid problems like this. Having what will amount to duplicate data in two different fields in your database, or two different tables in your database. Always want to avoid that. Always want to design before you go and implement. There's a law in software engineering, systems analysis and design, project management, all of these related fields, that the earlier a defect is identified, the easier it will be to fix it. So for example, if you go ahead and implement this and you have director and actor in different places, and you have conflicting data about Ben Affleck. Let's say Ben Affleck gets married and he changes his name to a hyphenated last name because he wants to have the same name as his spouse. You're going to end up with Ben Affleck in two places. You're going to have to change it in two places. So you'd have to change his last name here, Ben Affleck Damon. You'd have to change his last name here, Ben Affleck Damon. It's possible for the data to get out of sync. If you change it to Ben Affleck Damon here and leave it Ben Affleck here, he's going to have two different names in two different places. You don't want to do that. So what would be more appropriate is to just have a person table, person entity, or a movie person entity. Somebody who has something to do with movies. I don't know what it is, but this is a movie person. And we keep both actors and directors in as part of that one entity. We have this entity called movie person, and this movie person can be an actor, can be a director, can be an editor. Maybe we want to add editors later. Maybe somebody might work as an editor and a movie person. I don't know. We want to always have make sure we're only putting data in one place in our database. So if you find yourself creating entities that might overlap, you want to possibly refactor your database or refine your designs, especially before you go and start creating any entities or any tables in your database. Now the same thing goes for production company and distributor. Walt Disney, for example, is both a production company and a distributor. So let's just do company or movie company. And movie company will be production companies and distributors. Stop it. Okay. This allows us to consolidate possible duplicates in our database. Now let's look at movie person. First name. Tell me, what data type should it be? Yes, varchar 32. Nobody's going to have a first name longer than 32. We might even go 16 on this one. It's entirely up to you, as long as you can justify it in your documentation. Varchar 16, probably for last name as well. Movie company. Let's do varchar 32. Address. Now, address, you have several options here. Address you can split out into line 1, line 2, city, state, zip, country, if you want to. And let's actually do that, just for demonstrations purposes. So address line 1 is going to be what? It's going to be, yes, it's going to be varchar. What length? Probably 64. So address line 1, address line 2, varchar 64 again. City is going to be of type, oh, I don't know. Come on, what is it going to be? Yell it out. I promise I can hear you through the internet. Yell it out. Come on. Good. Varchar 32. State. This is another tricky one. This one you have some options here. State could be the state spelled out. It could be the state's postal abbreviation. You've got a couple options here. Usually, we'll make it of type char 2. That is a fixed length 2-character field. So MD for Maryland, DC for Washington, DC, NY for New York, etc. That's one of your options. You can also make it a type varchar and be able to type out Maryland, Washington, DC, but that's an issue. Why is that an issue? You can type Maryland in some places, you can type MD in some places, you can type DC in some places. If you make it of type varchar and allow the user to type it in, It's possible those things could get out of sync. So you want to avoid that. And we also have the zip code. A zip is another one where you have some options here. Zip code, what could it be? It could be, that's right, it could be an integer. It could be a small integer. Because look at small integer. Small integer allows us to hold, actually it couldn't be a small int, because small int wouldn't allow us to hold something that began with something greater than 32,000. So it couldn't hold 64928. Couldn't hold 90210 either. So we couldn't use a small int. We could use an int. Can hold up to 2 billion. We couldn't use a small int. We can also use char of fixed length 5. And in the case of a zip code, I will usually go with char of fixed length 5. Why? Because zip codes can begin with zeros, and in those cases, the zeros are significant. For example, 00928. It's probably a valid zip code up in Maine or something. When you try to type this out, when you ask the system, display this value, and it's stored as an integer, it will eliminate the leading zeros. So you're going to have Anyville, Maine, 9218. And that's nobody's going to know what that's supposed to be. The two leading zeros are significant. And when you've studied algebra, you know all about significant figures. If you study chemistry and physics, you know all about significant figures. Because it's stored as an integer, these two leading zeros are not considered significant and they're not going to be displayed. If it's stored as a fixed length character field, they are significant and they will be displayed. So make these determinations carefully. I'm going to leave it as a character of fixed length 5. In the case of a zip code, I will not store it as an integer because the leading zeros are significant. The same thing holds true for something like a phone number and a social security number. So let's think about movie person, for example. Social security number should not be stored as an integer. Why should it not be stored as an integer? Because it could have leading zeros. 003549812 could be a perfectly valid social security number. The two leading zeros are significant, and if you try and print it out, they'll be truncated if you store it as an integer. So for a social security number, I will store it as fixed length 9. Hopefully that makes sense. Why I'm making these decisions. Let's compare it against release year. Release year, a year will never have significant leading zeros. 01910. We don't care about the leading zero. It's 1910. 02016. We don't care about the leading zero. It's 2016. We will never have a significant leading zero on a year. That's why we can use the integer for the release year or the character. But for social security number, 003123456, these two leading zeros will always be significant. If we store as an integer, they'll disappear. We want them to always be there. That's why we have to store this as a fixed length character field of length 9. I've actually run into issues in systems where somebody stored the SSN as an integer. And it always had to go through pre-processing. But if we were going to display it, we always had to check, what length is it? Is it of length 7? We got to put on 2 leading zeros. Is it of length 8? We got to put on 1 leading zero. If it's of length 6, we got to put on 3 leading zeros, etc., etc. It always had to be checked. So it was an extra thing that had to happen when displaying the social security number, when we really should just be able to display it and be done with it. So these are 3 good entities for our movie database. We might have lots more, but let's go with these. Now what we have to determine is our keys. A key can serve several purposes in a database. There are four different types of keys. There are super keys. There are candidate keys. There are primary keys. And there are foreign keys. Let's talk about all of these. A super key is any field or collection of fields that will uniquely identify a record. Any field or collection of fields that will uniquely identify a record. Let's look at our values up here. Oh, I'm sorry. Let's back up a little bit. Let's talk about the other data types. There is Boolean or bit. A Boolean or bit field is just yes, no. Yes, no, true, false, 1, 0. That's used when we want to represent if something is or if something is not. We also have date time. It's obviously a date and a time. January 1st, 1970, 11:14 in the morning. We could use date times here. Let's actually add one. Let's add date of birth to the movie person entity. And for production company, let's add a bit field. Let's do is active. So if a production company is defunct, is active would be false. If it's currently in operation, is active would be true. Let's make that a bit field or yes, no. Doesn't matter. We can call it whatever we want when we're designing. Bit, yes, no, doesn't matter. Boolean, all the same when we're designing our database. Now, when naming these attributes, and when naming entities for that matter, you should always use the longest name possible. Always use the longest name possible. Don't abbreviate anything. SSN. That's a no-no. We don't abbreviate things simply because we don't have to. In the old days, in the 80s, 90s, we used to have limits on the number of characters that a field could be, that a name could be. Maybe 8 characters was the upper limit, or 16 characters. And we were encouraged to abbreviate things. We were encouraged to use as little space as possible. But nowadays, database management systems will allow these things to be any length. And we want to use that to our advantage. Sometimes names can be cryptic. DOB. What the heck does that mean? Always use the long name to describe any field. And this could even be zip code. Always use the long name because there's no reason to use an abbreviation. When we use the long name, the database is easier to use, it's easier to maintain, it's easier to understand what the heck it's doing. One of the key attributes of software in its measurement of quality is something called maintainability. How easy is it to perform maintenance on this software? And if we create this database and we do something like FN, LN, DOB, SSN, etc. If we create all these cryptic field names, and we know what they mean now, but let's say 5 years from now, we come back and we haven't touched the database in quite a while. it's going to take us a little bit of time to get up to speed on what FN, LN, DOB, SSN all mean. AL1. It's going to take us a little bit to figure out what all of these abbreviations mean. So there's no reason to abbreviate anymore. And if we don't abbreviate, it's much easier to maintain our database and to figure out what everything is doing later on when we come back to it. It's also, if we're working as part of a team, and one of us creates the database and someone comes along and maintains it, it's easier for that person to come along and maintain it if everything just makes sense. We call that self-documenting code or a self-documenting system. There's no reason to write really extensive how-to manuals on how to maintain it if merely looking at it is self-explanatory. I can just look at the thing and know what it does, know what it's for. Now you might say, well, typing all this stuff out is time-consuming. I don't want to type out social security number when typing SSN is faster. Many systems nowadays have autocomplete. That is, if I start typing SOC, it'll try and say, did you mean social security number? And all I have to do is say yes, and it'll finish typing it for me. If you've ever gone into a Google search and typed something in, it'll suggest searches for you. Same thing occurs with many modern database management systems. If you start typing a field name, it'll type the rest of it for you and suggest the rest of it for you. So it's much easier now. They've made things very simple. There's no reason to abbreviate things. You don't have to. It's much easier to maintain the database if you don't abbreviate things. All right. Now there are other data types, but these are the ones that are most common. There's also var binary. And var binary, just like var can have a different length. So var binary, it's usually max, because we have no idea how big this thing is going to be, or if it's going to be as at most 1024, something like that. Inside Microsoft Access, this is called image, or it's sometimes called blob. Blob means binary large object. They all mean the same thing. It's just whatever database management system you're using, it might hold different things. The blob data type is used for storing binary data, images. So for example, you might have movie person, so for a movie, you might have cover art. Will be of type blob, binary large object. It would store an image of the cover art. Nope, still want to do that. Right? Any questions? Sorry, you can't ask questions because you're not actually there. You can always rewind and rewatch things if something is unclear. All right. So this is a nice start. Now, let's go back to keys again. We have super keys. Super keys is any field or collection of fields that will uniquely identify a record. And they're called super keys because we can use them to identify a record. So let's look at movie, for example. What field or combination of fields will allow us to uniquely identify a movie? Think about this for a second. Let's look at title. Titles aren't unique. I'm sure there have been several movies that share the same title. Can't think of any off the top of my head right now, but there have been. So title itself can't be a super key. What about title and release year? I doubt that there has been the same movie title in the same release year. Production companies just wouldn't do it. They wouldn't release the same title in the same release year. I also probably think that trademarking or copyright probably wouldn't work there either. So we could probably use title plus release year to uniquely identify a movie. Nutty Professor, for example, or The Nutty Professor, was released in the 60s with Jerry Lewis, was released in the 90s with Eddie Murphy. So, The Nutty Professor, 1960-something. The Nutty Professor, 1990-something. That will allow us to uniquely identify these movies. So, title plus release year is a super key. Let's keep track of these. What's another super key? Now that you've gotten the hang of it, another super key could be what? Could be, you know what? Cover art by itself is a super key. Cover art by itself is going to be unique. I don't think there are any movies where they have exactly the same cover art. It's always going to be different. So that probably is a super key. Synopsis by itself is probably also a super key. I can't think of any movie that has exactly the same synopsis. Many movies are pretty much identical, like My Best Friend's Wedding and Maid of Honor. They just swap genders. But no movie has exactly the same synopsis. It's going to be vary slightly. So that by itself could be a super key. It's going to allow us to uniquely identify the movie. Now, what about release year? Obviously, release year is not going to be a super key because there are going to be hundreds of movies released in 2016, hundreds of movies released in 2015, 14, 13. That's definitely not going to be a super key. Rating is definitely not going to be a super key because there are only 6 possible values for it. Now, I said it's any key or combination of keys. So it's important to remember that any super key plus any other key is still a super key. Title plus release year plus rating. Because this will allow us to uniquely identify a movie, this will also allow us to uniquely identify a movie. Title plus a release year, Nutty Professor, 1960-something. Nutty Professor, 1960-something, G. It'll still allow us to uniquely identify a movie, even if we add extra stuff to it. Title plus release year plus synopsis. Combining 2 super keys will still give us a super key. All of these things are super key. There are many more. Title plus synopsis plus release year plus that is also a super key. All of these things are super keys. Any field or combination of fields is a super key. It will allow us to uniquely identify a record. If we are given this information, and only this information, we will be able to go in the database and find everything else. If we're given this information, we'll be able to go in the database and find everything. If we're given this information, we'll be able to go in the database and find everything. Those are our super keys. Now, there are also candidate keys. And a candidate key is a minimal super key. A minimal super key. That means I can't take away a field and have the thing still be a super key. For example, if I've got title and release year, if I take away release year, we've already established that title by itself will not allow us to uniquely identify a record because there could be 2 movies named The Nutty Professor. So title plus release year is also a candidate key. It is a minimal super key. Now let's look at title and release year and rating. Can I remove something from this and have it still be a super key? Yes, I can remove rating. I can remove rating and then I can still use title and release year to find the movie. So title plus release year plus rating is not a candidate key. Same thing with title plus release year plus synopsis. I could remove synopsis, and it will still be a super key. So it's not a minimal super key. Title, synopsis, release year, and cover art. I could remove cover art. I could remove release year, and it'll still be a super key. I could remove just cover art, and it'll still be a super key. Therefore, it is not a candidate key. It's not a minimal super key. Let's look at cover art. Any single valued super key is also a candidate key, because obviously we can't take anything away from it and have it still be a candidate key. So cover art, can't take anything away from it, so it's still a candidate key. Synopsis, can't take anything away from it, and it is still a candidate key. These are the three candidate keys in this entity. So I'm going to remove the super keys. These are the three candidate keys: title and release year, cover art, and synopsis. Just three. They're called candidate keys because each of them has an equal claim at being the primary key. And the primary key is simply the candidate key we happen to select. Theoretically speaking, all of the candidate keys have an equal claim at being the primary key. So we can use title and release year as the primary key. That's called a dual valued primary key. It's perfectly acceptable to have two fields be required to be the primary key. Cover art can be the primary key, or synopsis can be the primary key. Now there's an issue, however. So in theory, from a standard database theory perspective, all three of these have a perfectly legitimate claim at being the primary key. But from a practical perspective, each of them has issues. Title plus release year. Dual valued primary keys are annoying. You do not want to deal with them in a database. They're allowed, and from a theoretical design perspective, they're perfectly valid. But you don't want to have to deal with them. Because whenever you want to uniquely identify a record, you're going to have to find two values. You're going to have to find title and release year. There's two things you have to check instead of one. Does it match this one and does it match this one? You don't want to have to do that. It's annoying. It's extra work for you when you're doing your reports and your queries and your fields and your forms, and it's extra work for you. You don't want to do it. Cover art is a blob. It's unstructured data. It's just a bunch of binary bits. It's an image. It also could be possibly be very large. We don't want to have to pass around this image to try and find a movie. Now, it might be recognizable to a human. I can recognize that this is the cover art for the Power Rangers movie. But it's not easily recognizable for a computer. Storing, if you're going to search for the cover art, you're going to have to find some way of like saving the image and inputting into the database. It's going to be a mess. So it's not something that you want to be passing around and to use as the primary way of identifying this record. Remember, the primary key is the primary way that you identify this record. It's the thing that you pick. That whenever I look for this record, this is what I'm going to use to find it. So you don't want to pick cover art. The same thing goes for synopsis. It has the potential to be very large. It's also unstructured. As I said, it's just a bunch of words that have no real semantic meaning outside of your database. So all of these have problems. And theoretically speaking, they're all perfectly valid primary keys. But practically speaking, we don't want to use them. So in this case, what we will usually do is we will assign a serial number to the entity. And this serial number will have absolutely no meaning outside of our database. And all it is used for is internally to represent this record. So, and the serial number is usually called the ID field. And most databases, excuse me, most databases will allow you to create an auto number field. As a matter of fact, Microsoft Access, which we will see in a few minutes, automatically creates an ID field that is auto numbered. On every table you create, it automatically puts it there for you. Most systems, this is what's done. Even if there is a valid primary key that could be used, like a single valued structured primary key, usually the system will still do an auto number ID field just because it's simple, it's easy, and it allows for uniformity across all entities. If you're creating your database and you want to use title and release year, fine. It's perfectly valid. Not the best decision practically speaking, but from a theoretical perspective, there's nothing wrong with it. So, candidate keys. Any field or combination of fields that will allow us to uniquely identify a record. Sorry, that's super key. Super key is any field or combination of fields that will allow us to uniquely identify a record. Candidate keys are minimal super keys. That is, I can't take anything away from it and have it still be a super key. And primary key is simply the super key that we pick, the candidate key that we pick to be the one that we use to uniquely identify this record. And when we pick it, we underline it. Primary key is always underlined. Now let's talk about movie person. This one has a very natural primary key. So let's skip all the formalities of finding the candidate keys and super key. Social security number, it's obvious. Social security number is obvious to be the thing that we should use to uniquely identify this person. However, although, again, from a theoretical perspective, social security number is perfectly valid to use as the primary key. From a practical perspective, there are problems with it. The practical problems include, if you are using a primary key, it encourages the sharing of that key. So if you're looking up a movie, you say, okay, I'm looking up a movie. Hey, Joe, I want to find this movie. Well, what's its ID number? It's ID number 35. It encourages people emailing back and forth this information. It encourages people giving this information over the phone. When you use something as the primary identifier, people tend to share it because it's the thing that you've picked in your database to find this person. And when we start sharing stuff, and when we start making it okay or acceptable to share stuff, we run the risk of this information being stolen. Let's say I want to send a list of all movie people, and I want to be able to find these people in my database. I'm going to want to include the primary key. If I include the primary key, I'm going to include the social security number if I pick that as a primary key. And I could email this, and it could be captured in transit. But if I use an auto-numbered ID field and omit the social security number, I can still find these people in my database. But I don't have to worry about somebody intercepting this sensitive information. Additionally, you usually don't want to use a primary key that is sensitive, whether that's the SSN or anything else. You don't want to use something that has the potential for abuse or misuse. Because not only outside of your organization, You have people who would steal your stuff. You have people inside of your organization. You will always safeguard your information and only include stuff that you uh, only give people access to information that they should have access to. In this case, an ID number, an auto-numbered serial number, is much safer to pass around, to email to people, because it has no meaning outside of your organization. If somebody knows that Mighty Morphin Power Rangers, the movie, is ID number 35, that is meaningless outside of my organization. Or somebody knows that who directed this movie? Doesn't say. Oh, Brian Spicer. If somebody knows that Brian Spicer's ID number in my system is 28, that is meaningless. But if somebody figures out that Brian Spicer's social security number is 123592984, then we have an issue. So social security number theoretically is perfectly valid. If you want to design your system like this, go right ahead. But you're going to upset the information security people. So in this case, I would pick an auto-numbered ID field. Let's move on to movie company. Again, we'll skip the formalities. Let's look at what are the candidate keys here. Name is probably a candidate key. All movie companies are uniquely named. The combination of the address is probably unique. So address line 1, address line 2, city, state, zip is probably another candidate key. So therefore, this combination of fields, the address and the name, are the two valid candidate keys in movie company. And we could pick name to be the primary key. And unlike social security number, if the name gets out, we don't care about sharing the name. It's fine. We can share the name. It's not protected information. And if you want to pick name as your primary key, that's perfectly acceptable, perfectly valid. There's really no practical issue with it either, because it's a small structured value. But for consistency's sake, I would still recommend another serial number. So there we have our three entities and our chosen primary keys. Now let's move on to Microsoft Visio. I'll delete this. Microsoft Visio is how we design the structure of our database. Come on, delete. I've started out creating a database diagram, and I can drag over an entity. And this is very easy to do. I just change its name, so we change a movie. And it automatically comes with a primary key. The primary key is going to be ID of type auto number. It's going to have an attribute. Title. Of type varchar 32. Synopsis. Of type varchar 1024. Can drag over more attributes. Rating of varchar 5. Release year. I'm going to use small int here, and I'm going to use a fixed length char in the other ones, and show you what the difference is. And cover art. I'll type blob. So there's movie. Let's move that over here. Make another one. Movie person. ID auto number. Social security number. Char of length 9. First name, last name, and date of birth. 32 or 16? 16. Oops, don't want that yet. And date of birth. Let's talk about date of birth for a few seconds. You might be tempted to use age, maybe, or yeah. Let's use age for as an example. I typically will only store one value, and if I can infer another value from it, then that's all the better. So instead of storing age, I'll store date of birth, and if I ever need the person's age, I can just subtract it from today and figure out the person's age. So date of birth allows me to get two things. It allows me to get the date of birth as well as the age. If I'm just storing the age, I can sort of approximate the year the person was born, but date of birth gives me the most information if I store it that way. Right. Move movie person over here. Let's do production company. Again, we have ID, which is an auto number field. Name. I think we'll do 32 or 64. 64, 32? 32. Address line 1. Character 64. Address line 2, varchar 64. City state zip. Varchar 32. State care of exactly length 2. Zip code care of exactly length 5. And is active type bit. And there are our three entities: production company, movie, and movie person. Now you're thinking to yourself, a movie person has a director. How do we associate, or sorry, a movie has a director. How the heck do we associate movie with movie person? How do we say that this is the director? We use the fourth type of key, which is a foreign key. And a foreign key is the primary key value of an associated record. The primary key value of an associated record. So movie. If I want to find out the director of this movie, I'm going to need to know the director's primary key, or the director's ID. If I want to know the director, I need to know the director's ID. So that becomes a foreign key inside of the movie table director ID. This is a foreign key. I can mark it as a foreign key. Director ID is of type integer. It's a foreign key. And the way I show this relationship, I drag over this little relationship thingy. And I match director ID with the associated primary key field right there. Now you'll notice there are little markings here. There's this little 1, 1 here, and this little dot and lines here. This is called the cardinality. Cardinality tells me how many of these things are related to each other? Cardinality. So, every movie has how many directors? A movie can only have one director. A movie person can direct how many movies? Can direct many. So actually, these need to be reversed. Come on. That's what this means. This means zero or many. That's actually not a circle. It's a zero or many. We can change this. So 0 or more, right there. 0 or more. And on the other side, 1 and only 1. Exactly one director. So every movie, we follow the line over here, has exactly one director. A movie person, follow the line over here, can direct 0 or many movies. A movie, follow the line, can have one and only one director. A movie person, follow the line over here, can direct 0 or more movies. That's how we determine this. And you can change this if you need to. Make sure the cardinality is correct when you create your fields. Now you may have noticed we can also mark something as required. When we mark something as required, that means it cannot have a blank value. It must have something in there. I'm going to mark all of these things as required. And obviously the primary key is always required. There's no reason that any of these should not be required. Let's leave date of birth blank. We don't really need that. Production company. ID should be required. Name should be required. Address line 1 should be required. We probably don't need address line 2. Usually that's optional. We need the city. We need the state. We need the zip code, and we need to know whether it's active. So, a movie also has a production company associated with it. How do we add the production company? Exactly. We add a foreign key to the production company. Production company ID of type integer. And that's required as well. And it's a foreign key. When naming foreign keys, I will usually name it the target entity, so director, and the primary key field's name, ID, director ID. I didn't call this movie person because it's specifically the director. And there could be other movie persons, it could be actor, it could be editor, it could be producer. And those would all go to movie person. So when naming foreign keys, now this could vary depending on your particular organization and how your organization works. But when I name it, I always name it whatever thing I'm referencing in the foreign key field name. So production company ID. Actually, sorry, that wasn't production company. It was movie company, I think we called it. Yeah, movie company. Movie company. So production company ID, and we also have distributor ID. I'll type integer. Come on. And it's required, and it's a foreign key. And we can do the cardinalities, or sorry, we can do the relationship. Production company ID is linked with movie company ID, and distributor ID is linked with movie company ID as well. Now let's look at cardinalities. A movie can have how many movie companies? In this system, we're assuming a movie can only have one. So therefore, we need to change the cardinality here. We need to follow it along. It's not many. 1. And a production company can produce how many movies? Can produce many, so the end symbol is 0 or more. See that over there? Now, same thing with distributor. A movie has, in our rules, a movie has one distributor. So one and only one. And a movie company can distribute any number of movies. Make sure your cardinalities are reflected here when you create your entity relationship diagram. So there's our entity relationship diagram. It's nice. It's simple. If you want to get a little more complex, we can talk about many-to-many relationships, which are not able to be modeled in the traditional relational model. Many-to-many relationships require an intermediary. So what we might do, I have many people who could star in this movie. Ben Affleck, Matt Damon. I have several options. I can say star 1 ID, star 2 ID, star 3 ID, and so on. That's one way I could do it. And I just fill them up until I don't have any more room, or until I've used up all my stars. But that's annoying. I put Ben Affleck here, put Matt Damon here. It gets unwieldy. What if there are 20 people who starred in the movie and I want to keep track of them all? I have to have 20 different fields. So we're not going to do it that way. If you find yourself wanting to create a many-to-many relationship, that is, many movies have many stars, and many stars have starred in many movies, what you can do is you can create an intermediate table. And you name it after the relationship. Stars in movies, or students in classes. Many students can be in many classes, and many classes have many students. Stars in movies, students in classes. You're doing a human resource information system and you want to keep track of people and jobs. Person in job. A person can have many jobs over the course of his lifetime, and a job can be filled by many different people over the course of the job's existence. So stars in movies, people in jobs, students in classes. Anytime where you are linking many things with many other things, you need an intermediate way of associating them. And it usually has an ID as well. And all it really has is foreign keys. This table's whole existence is to link movie with a star. So it only has foreign keys. What foreign key would it have? It has movie ID of type integer, and has star ID of type integer. There's one thing we might also put in here. We might put in the role. Maybe varchar 16, the name of the role the person played. That's not required. And it's a foreign key as well. And we can go ahead and add the relationship notation. There we go. Okay. Sometimes Visio doesn't like to make these things look pretty. That's all right. There we go. So let's look at the cardinality to make sure it's correct. A particular time that a particular person is in a movie is associated with one and only one movie. So this cardinality needs to be fixed. And a particular time that a particular movie has a particular person starring in it happens one and only one time. Can happen many, many times. So a movie has many stars in the movie. A particular role for a particular person can only be associated with one movie. Let's look over here. A person can star in many movies. So we go for movie person, we follow it over here, many, many roles. A particular role for a particular person can only have one person. So we have the one notation over here. This is a complete entity relationship diagram for a movie database. Now we can go to Access and create it. Notice this automatically creates the ID field when I create the new table. I like to look at it in design view. I'm just going to want to save it. Movie company. It automatically creates the ID auto number field for me. So I'm going to leave that alone. It automatically marks it as the primary key, this little key field right here. Automatically marks it as the primary key. Let's add these. Name. This is going to yell at me. Yeah, it's going to yell at me when I create the name because name is a reserved word in Microsoft Access. And I have to do some special stuff when I create queries and things when I use a reserved word. But that's fine. Now, Microsoft Access has particular data types, and they might be different. Short text is the one we're going to use for this, and it's going to make it of type of length 32. So make sure you change this. Format we're going to leave alone. All this other stuff we're going to leave alone. Address line 1. Oh, we're going to make it required. Required, yes. Address line 1. Leave it as short text. It's going to be of max length 64. Required, yes. Address line 2. Short text, max length 64. Make sure you change all these. You don't want to create your database with just type in whatever you want. Make sure you always restrict the values. The more you restrict the values, the more structured your database will be, the less room for anomalies you'll have, and the more clean your data will be. If you restrict what your users can type in, you're going to enforce that your data are clean and they meet all of your constraints. So make sure you always put those constraints in there. City. Type short text again. We're going to make it of length 32. State. Exactly length 2. Input mask. Let's click this. Yeah. Input mask. There are several that are predefined. Phone numbers, etc. I'm going to define my own. This notation you're going to want to look up. I believe it's just underscore for values, and then underscore is a placeholder. Sample data is DC. For input. Oh, geez, I know that's okay. Ugh. make sure of something. Oh, there's extra space over there. Oh, I don't want to change that. Go away. Okay, I don't want to use an input mask. I want to use a validation rule. And this is where it gets a little complicated. You can probably look online and find a good validation rule for a state. Make sure if you're going to submit this for an assignment, if you go online and find a validation rule for a state, including your assignment documentation, this is where I found this, so you don't get hit for plagiarism. What I'm going to do is I'm going to say state is equal to AL, or state is equal to AK, or state is equal to AZ, and I would do that for all of them. What this enforces is state is equal to Alabama, or Alaska, or Arizona. I'm going to add a couple more, or state is equal to DC, or state is equal to MD. And we would do that for all 50 states, Guam, Virgin Islands, any valid states that we wanted to have. We say it is required. Allow zero length. Well, it doesn't matter, but allow zero length, no, of course. And that'll work for us. So let's save this, and I'll show you how this works. I'm going to double click this and allow me to open it up in edit mode. Can I zoom? I can't zoom. So let's insert a production company. David code. I live at 123 anywhere place. I'm going to leave the city blank and show you what happens. It fails validation. Oh, line 2 is required? I thought I didn't make line 2 required. Go away. Oh, I did make line 2 required, so let's change that. All right, so let's do David Co again. 123 anywhere place. Let's leave it alone. State is required, so it's telling me I need to put it in there. So let's put state in there. Okay. I'm going to put one of these that I didn't do. I'm going to do Guam. It fails validation. I put something that didn't meet this requirement. State is either Alabama, Alaska, Arizona, DC, or Maryland. It failed validation. That's what something I can do there. So I'm going to put in DC instead, and it works. Actually, it looks like I didn't make city required, so let's make city required. Let's make city required. That's fine. Okay. And California is not going to validate. It fails the validation requirement. So maybe it's Alaska. So there is our movie company. Let's close it. Create a new table. I usually like to do design view. I'm going to call it movie this time. Automatically creates the ID for us as an auto number. Just leave it. There's no reason to change it. Title of length 32. Required, yes. Synopsis. 255 is the largest it can be. It's going to have to be long text. Okay. It's required. There we go. Rating of length 5. Here's another one where we need to do a validation rule. Required, yes. And this I'm going to do the entire one. Rating equals no rating, or rating equals G, or rating equals PG, or rating equals PG-13, or rating equals R, or rating equals NC-17. That's my validation rule. Rating has to equal any one of those things. Release year. Here's where I can use a different data type. I'm going to use number. And here's where we get to pick what size it is. It's not going to be a long integer. It's going to be, come on. Why is that not working? I should have options of changing. Hold, please. I apologize. I can't figure out why I can't pick anything besides long integer, but yeah, fine. We'll leave it. All right. We want to make it required. And we want to use a validation rule. So we say release year is greater than 1910. And release year is less than or equal to this year. That's kind of cool. What we can do, we can say year of now. Release year is at least 1910 and is less than or equal to now. Validation rule. And you can look these up. Well, there's all different kinds of stuff you can do. As long as it makes sense and it works for the type of data you're using, it's perfectly fine. Right. So release year. Cover art is of type image, not image, attachment. There we go. We'll make that required as well. Attachment is the blob data type specific to Microsoft Access. Director ID is also type numeric and is required. Production company ID is a type number. And distributor ID. Now let's talk a little bit more about maintainability. You're probably going to want to fill in these descriptions. If you're using, say, a data dictionary, it's not as crucial because your data dictionary is going to contain all this information. So if you have any validation, you're going to want to put that in here. Put the validation information in here, because otherwise your user's gonna have to decipher your validation code. So if you're gonna put any validation in here, put information about how it needs to validate. Something like that. All this stuff here. So your user knows what the heck to type in here. You don't want to fill these in. That's, again, maintainability, and it's also for usability in the case of Microsoft Access. All right. And okay, we got distributor ID. And then we have movie person. Movie person has a social security number. Now this one has its own input mask. We can say yes. We can say it's definitely a social security number. Of length 9. And it's required. We also have a first name. This works for phone numbers, zip code, all that fun stuff. First name of length 16. Last name of length 16. And required. And required. And date of birth. Type date time. We decided we weren't going to make date of birth required. Yes. Now, date of birth can also have different input masks. It's just going to say how it should be inputted. We'll just use that one. The short date. Easy. Always use input masks if you're going to use Microsoft Access. It makes maintaining your database and inputting data a lot easier. Now we're going to have one more table, and that is stars in movies. We have the movie ID, the star ID, and we have the role of length 16. Those are all of our tables. Movie, movie company, movie person, stars in movies. Now, to create these relationships, we go to relationship and we add all of our tables in here. Make them look pretty. To create a relationship, we simply drag from the foreign key to the primary key. So, director ID is associated with movie person. Just drag it over. It'll bring up this little dialog. This, if you did it right, is going to be exactly what you wanted. You wanted the primary key table and the foreign key table. You're almost always going to want to enforce referential integrity. Referential integrity means I can't create the foreign key without the primary already existing. There's no point in even having the relationship if you don't enforce referential integrity. If you don't enforce referential integrity, you'll be able to create foreign keys that have no associated primary key, and that makes no sense. Cascade and delete are almost always going to be marked as true as well. There are some times when you wouldn't. Cascade update means if you change the primary key, it will automatically go and fix all of the associated foreign keys for you. You don't have to do it. If Cascade update is not checked, and you change the primary key's value, you have to first go in and change all of the associated foreign key values first, and then go change the primary key's value. So you're almost always going to want to have cascade update checked. Cascade delete is a preference depending on your system. If cascade delete is not checked, and you try to delete the foreign key value, it will not let you do it if there are any foreign keys. So if I've got a movie, if I've got a movie and I have lots of movie persons, and I try and delete the movie person that's associated with the movie, it won't let me do it if cascade delete is checked. Or sorry, if cascade delete is unchecked, it won't let me do it because movie person is associated with the movie as a director. So if I've got Ben Affleck over here, and I've got, I don't know, Argo over here, and I try and delete Argo, it won't let me do it because Ben Affleck is still over here. Or wait, nope, sorry, other way around. I apologize. Ben Affleck is over here, Argo's over here. If I try and delete Ben Affleck, it won't let me do it because the movie is still referring to him over here. I have to delete the movie first, then delete Ben Affleck. Anything else is he's associated with. However, if cascade delete is on, and I delete Ben Affleck, it'll automatically delete any movie that he directed. And you might and might not want to do that. So it's a preference, depending on your data and how your system is set up, whether or not you want cascade deletes on. I'm going to leave them on. I usually leave them on. Okay. Need to close all the other. So I grab director, associated with movie ID, enforce referential category, cascade. Now you'll notice these little symbols here. This is the way Microsoft Access denotes cardinality. This, it looks like a little chain. It's actually an infinity symbol. And an infinity symbol is just another way of showing this, the many portion. So a movie person can be associated with many movies. A movie person can be associated with many movies. It's just an infinity symbol. And a director can direct one movie. A movie has one and only one director. So it's just a different way of showing cardinalities. Any of them is perfectly valid. Whether you want to do the crow's foot notation is what this is called, or this is Microsoft Access's way of doing it. Distributor ID. I take it over here, drag it over to movie company, enforce, cascade, create. Production company ID. Drag it over here. Forget which one I created there. Production company ID. Drag it over here. Enforce, cascade. Distributor ID. Drag it over here. Enforce, cascade. No, it wants to do it that way. Sure, why not? It created a new copy of movie company. I don't know why, but this is just it denotes two different relationships. And now stars and movies. I can put over here. Movie ID over there. Enforce, cascade. Star ID. Drag it over there. Enforce, cascade. And there are all of our relationships. We can make it look pretty. Arrange it nicely. And there you have all of your relationships. Same thing as these. And that is how you create a database in Microsoft Access. Now, there's a lot more in Microsoft Access to do, but we have been at this for over an hour and a half. This is a lot for you to read and to watch in one sitting. So go ahead and practice with Microsoft Access. Practice with Microsoft Visio. Practice creating entities, picking foreign keys, picking primary keys, looking at candidate keys, deciding what you want to pick as the primary key, all that fun stuff. So there's lots of stuff to do. Go play with it. Have fun. And I'm going to make lots more videos for y'all to watch. But for now, hope you enjoyed Microsoft Access. And as always, thanks. That's all. Bye bye.